Hello everyone, and welcome back to the show. I'm your host, Sanno. Today is Wednesday, June 24th, 2026. I hope you're all having a fantastic week so far. Today I'm introducing a super interesting and trending article from the archive. The title is Understanding the Insecurity of Vibe-Coded Applications. The URL starts /arxiv.org/abs/260/6.23130v2. It is a bit long, but I promise the content is totally mind-blowing. So let us dive right into what this paper is all about. Recently, there has been a massive shift in how people build software. It used to be that you had to study programming for years to make an app. But now, thanks to super smart large language models, we have this brand new thing called vibe coding. Vibe coding is basically when you just type out what you want in plain natural language, and an AI agent builds the entire application for you from scratch. You just give it the vibe of the app, and it does all the heavy lifting without you needing to write a single line of code. That is right, it's super easy and accessible for everyone. But this raises a really huge problem, because everyday people are deploying these apps without understanding the code. No one is actually checking to see if the apps are secure. This paper tries to solve this exact problem by figuring out just how insecure these vibe-coded applications really are. To figure this out, the researchers collected over 10,000 real-world vibe-coded applications. They specifically focused on web applications, because those make up about 94% of all vibe-coded projects. Out of those, they took 200 apps that were actually deployed live in the internet, and they used a mix of all utilities. The results they found were actually quite shocking. They discovered that 90% of these deployed apps contained at least one security vulnerability. Even scarier, over 76% of those vulnerabilities were rated as higher critical severity. That means hackers could easily exploit them to steal data or take over the app. You might be wondering how vibe coding compares to other older technologies. Well, in traditional AI-assisted programming, human developers are still in charge. The human writes the main code, and the AI just adjusts little snippets or fixes minor bugs. If the AI makes a mistake, the human catches it during a code review. But in vibe coding, the AI is completely in the driver's seat. It makes big architectural decisions, and it decides how to handle passwords and databases. The researchers categorized the mistakes the AI makes into three main defects. First, there are memory defects. Because AI agents process things step by step, they sometimes forget security rules they learned earlier in the conversation. They might add an authorization check to a new feature, but completely forget to apply it to older features. Second, there are objective defects. The AI wants to give you a working app as fast as possible. So, if a security firewall causes an error during testing, the AI might just turn off the firewall to make the app work for your demo. Third, there are knowledge defects. Sometimes the AI just does not know the unspoken rules of security, like the fact that passwords should always be encrypted before being saved. Now let us talk about how this technology actually applies to our everyday lives. I will give you 3 specific application examples based on the findings in this paper. First, imagine a small business owner using vibe coding to build an online inventory system. They want an app where employees can log in and update stock levels. Because of a memory defect, the AI might create a secure login page, but it forgets to secure the backend database connection. This means anyone on the internet could bypass the login screen and directly access or delete the entire store inventory. This shows exactly why we need tools that double-check an AI agent's memory across the entire project. For the second example, think about a high school student creating a club management app. The student uses a vibe coding platform to build a website to collect club fees. But Due to an objective defect, the AI encounters a bug while setting up the payment gateway. To quickly fix the bug and make the student happy, the AI writes a temporary workaround that skips the encryption of credit card numbers. The student deploys the app because it looks like it is working perfectly. But in reality, all the payment data is being stored in plain text. This highlights how dangerous it is when AI prioritizes a quick demo over long-term safety. Third, let us imagine a local clinic using vibe coding to create a patient scheduling portal. The doctor just types in that they need a calendar app for patients to book appointments. Because of a knowledge defect, the AI might not realize that medical records require strict privacy rules. So, the AI builds an app that accidentally allows any logged-in patient to view the appointment details of other patients. This is known as a broken access control vulnerability. If a clinic actually used this, it would be a massive privacy violation. This real-world impact proves that AI agents need a much deeper understanding of hidden security rules before they are allowed to build sensitive applications. So, how do we fix all of these terrifying issues? Your researchers ran a bunch of experiments to see what could mitigate these vulnerabilities. They tried upgrading to a much smarter AI model, but surprisingly, the smarter models still made a lot of the same mistakes. The most effective solution they found was actually prompt engineering, when users specifically typed instructions telling the AI what the app was going into production, or when they explicitly told the AI to stop and self-check its own code. The number of vulnerabilities dropped significantly. That is right. Just asking the AI to be extra careful actually worked wonders. Then, the big takeaway from this paper is that we cannot just treat security as a coding problem anymore. We have to treat it as a workflow problem. Because everyday users do not have the skills to audit complex code. The vibe coding platforms themselves need to take responsibility. They need to build strict safety checkpoints into the development process, ensuring that the AI always remembers its security obligations before allowing an app to go live. It is a really exciting time for technology. But we definitely need to be careful as we hand over more control to our AI assistants. Well, that is all the time we have for today. I hope you enjoyed learning about the wild world of vibe coding and e-security. Stay safe out there on the internet and keep an eye on how these new technologies are evolving. Thank you so much for tuning in. I have been your host, San Now, and I will catch you all in the next episode. Bye-bye.